Hi again. This is part 2 of the lesson Analyzing Data. The range of a set of data is the difference between the maximum value and the minimum value in that set. Now, if you have a set of data, the median will divide this set to two equal parts. If you find the median again for this part, you will have two more parts. If you find the median for the right part, you will have two more parts or quarters. These three medians will divide the set to four equal parts or four quarters. This value here is called the first quartile. Here, this is the second quartile and this is the third quartile. The interquartile range is the difference between Q3 and Q1. Actually, the range and the interquartile range are two important values to compare between data sets. A percentile is a number from 0 to 100 that indicates the location of a value or a score in a distribution. Suppose that you scored at the 40th percentile on your biology exam. This means that 40% of the scores in your class are less than or equal to your score or your mark. Another example, if your score is at the 63rd percentile, then 63% of the data are less than or equal to your score. In math, we mostly prefer to deal with plots because they give a better representation of the information. One of these important plots is the Box and Whisker Plot. This plot is a way to display data that uses quartiles, the first, the second, the third, and the minimum and maximum values of a set. How can we construct a Box and Whisker Plot? Let's learn now. We will study how to construct a Box and Whisker Plot for two cases. When you have a set of an odd number of values and when you have a set of an even number of values. This set here contains 11 numbers and this is an odd number. Firstly, to be able to find the median, we need to order these values from least to greatest or in an ascending way. 3, 5, 5, 6, 9, 12, 15, 17, 20, 23, and 25. As we learned before, to find the median, we cancel out one value from each side at a time. If we cancel out these, 12 is left. So 12 is the median. Now, 12 divides the set to two equal parts. We have one part to the left and one part to the right. For this part, we will find the median. If we cancel out one value from each side, we get 5. This is Q1 and the median here is Q2. If we find the median of these values, it is 20 because this is the value in the middle. So this is Q3. The minimum value is 3. And the maximum value is 25. You need to make sure that the minimum and maximum values are not outliers. If they are outliers, we don't include them in the box plot, but we're not going to study this now. To make the box plot, we draw a number line. The minimum is 3 and the maximum is 25, so let's start at 0 with a step of 5, 10, 15, 20, 25, and 30. The minimum value is 3, it's almost here. The maximum value is 25, it is here. The first quartile is 5, it's exactly here. The second quartile is 12, right after the 10. The third quartile is 20. Then we make the box by connecting the quartiles and then we connect the minimum and maximum values. This is the minimum, this is the maximum value, this is Q1, Q2, and this is Q3. To find the interquartile range, we subtract Q3 minus Q1, or 20 minus 5, which is 15. The range is the maximum and the minimum, and make sure that you differentiate between the interquartile range and the range. The range is 25 minus 3, or 22. The range and the interquartile range represent how wide the distribution of data is. Now, this is another case. These are 10 numbers, and this is an even number of values. Again, to find the median, we need to order them. 3, 5, 6, 15, 17, 20, and 25. So the median is 13.5, which is between 12 and 15. Now we need to find the median of this set, which is 6. And this is Q1, the first quartile. This is here, the second quartile. And the median of this set is 20. This is Q3, or 20. Again, we make a number line. The numbers are between 3 and 25. This is the minimum, and this is the maximum value. So we start from 0, 5, 10, 15, and 30. The minimum is almost here, 3. The maximum is exactly 25. The first quartile is 6, right after the 5. The second quartile is 13.5. It's between 10 and 15. It's more than half of the distance here. And the third quartile is 20. Again, we connect the quartiles. Then we connect them with the minimum and maximum. This is Q1, this is Q2, and this is Q3. The range is 25 minus 3, or 22. And the interquartile range is Q3 minus Q1, or 20 minus 6, which is 14. Now let's see how we can apply that on a real-life example. The table shows average monthly water temperatures for 4 locations on the Gulf of Mexico. How can you compare the 12 water temperatures from St. Petersburg with the 12 water temperatures from Key West? So we need to compare the temperatures in these two lines, the city of St. Petersburg and the city of Key West. To compare the temperatures, we need to find the mean, the mode, the median, and the box plots for each of them to compare the range and the interquartile range. Let's start with the mean. This is for city 1 and this is for city 2. The mean of the values for city 1 is the sum of the temperatures over 12, because they are 12 values. The sum is 900 and the number of temperatures is 12, and this is equal to 75. The mean of the temperatures for city 2 is the sum of the temperatures again, which is 949 over 12, and this is equal to 79.1. The mean here is higher than the mean in St. Petersburg. This indicates that the temperature in general is higher in this city. Now let's find the mode. For this city, there are 3 modes. 64 repeats twice, 84 repeats twice as well, and 86. So we have 3 modes, 64, 84, and 86. The modes for this city are 2. 82, it repeats twice, and 87, it repeats twice as well. So 82 and 87. To find the range, the interquartile range, and the median, let's construct the box and whisker plot. Firstly, we need to order the values for the first city. 62 is the minimum. Then we have 64, 64 again, 74, 84, 84 again, 86, and 86. The maximum is 86 and the minimum is 62. To find the median, again we cancel values to get 1 or 2 values in the middle. The median of this set of values is 76, or Q2, the second quartile. The first quartile is 66, and the third quartile is 84. Let's make the box and whisker plot now. We will start at 60 and we will end at 90. 60, 65, 70, 75, 80, 85, and 90. The minimum is 62. The maximum is 86. The first quartile is 66. Right after the 65, the second quartile is 76, and the third quartile is 84. This is our box, and these are the minimum and maximum values. To find the range, we need to subtract the maximum minus the minimum. 86 minus 62, and this is 24. The interquartile range is the difference between Q3 and Q1, and this is 84 minus 66, which is 18. Now let's do the same for QS city. For the second set of temperatures, let's order them first. 69, 70, 72, 82 again, 85, 86, 87, and 87. The median of this set is 80. It's the mean of these two values. This is Q2. The median of this part, or Q1, is 73.5. And the median of the other part, or the third quartile, is 85.5. This is Q3. Again, we construct the plot. This is 65. You can start at 65 because the minimum is 69. 70, 75, 80, 85, 90, and 95. Actually, you can stop at 90 because the maximum is 87. 69 is almost here. 87 is here. Now the first quartile is 73.5, almost here. The second quartile is exactly 80, and the third quartile is 85.5. It's almost here, just after the 85. This is the box plot. The range of these values is 87 minus 69. And this is equal to 18. The interquartile range is 85.5 minus 73.5, and this is equal to 12. If we compare the range and the interquartile range of these two sets, we see that there are more variations of temperature here because the range and the interquartile range are higher. So the temperature varies more in this city. After solving this example, we see how important these measurements are to compare between two things and for some statistics in real-life problems. Now, this is an easy question. Here is an ordered list. This is an ordered list of values. If it's not ordered, we need to order it to find the percentile. Here is an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? Of the 20 values, 65% are equal or less than the 65th percentile. 65% of the values, which are 20 values, if you count them, are less than or equal. 65 over 100 times 20 is 13. So 13 values are less than or equal to the 65th percentile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 65th percentile is 82. This is Griffith 5. What are the values at each percentile for the data in problem 5? A, 55th percentile. Now 55% of the values, which are 20 values, are less than the 55th percentile. 55 over 100 times 20 is 11. So 11 values are less than or equal to the 55th percentile. Let's go back to the numbers to see. The value number 11 is 79, so the 55th percentile is 79. The answer of B is 98. You can do it to check your understanding. This lesson was somehow hard, so you need to do all the questions in the homework to make sure that you understood every single point in this lesson. And this is a bonus question for my students. Make sure that you send the answers to my email or on Class Dojo. This is all for today. Thanks for watching.